To solve this linear inequality, we're going to use a graph. So I'm going to start by factoring the numerator. Let's see, we have to have a 2x and an x. I want to get, let's see, a -3, but also have a -5. I'm going to do +1 and -3. And for the denominator, let's see, that's going to be an x minus 6 and an x plus 5. So this will give me everything that I need to figure out the x-intercepts, the y-intercepts, the vertical asymptotes, as well as the horizontal asymptotes. The x-intercepts are going to be, let's see, -1/2 comma 0, and also 3, 0. That's where the numerator is equal to 0. The y-intercept is going to come from the last two terms, which is going to be 0, comma, it's going to be positive 1/10 after I simplify it. The vertical asymptotes are going to be x is equal to -5, but also x is equal to 6. That's where the denominator is equal to 0. And the horizontal asymptote is going to be the ratio of the first two terms of my original expression, which is going to be 2/1. So I'll just write y is equal to 2. So I'm going to sketch all this on here. We have y equals 2. And then I also have -5 and positive 6 for my vertical asymptotes. I have 0, 1/10, something pretty close to 0, -1/2 0, it's right about here, and then 3 zeros the other x-intercept, so my graph is going through those three places. Let's sketch the graph. It's going to come up, go through these 3 points, drop back down, and it's going to be above both sides. And the only other thing I'd have to worry about is, does this thing equal 2? Does it actually cross the horizontal? So let me write that. Does it cross its horizontal asymptote, which is y is equal to 2? Does that happen? So again, I'll take my original equation. I'm going to set it equal to 2. And all this is going to do is double the denominator after I multiply it to both sides. So 2x squared minus 5x minus 3 is equal to, so now I'm going to get 2x squared minus 2x minus 60. So I can again cancel the x squareds, those are the same. I think I'll add 60 and 5x to both sides. So if I add 60, I get 57 is equal to, if I add 5x, I get 3x. Dividing both sides by 3 gives me 57/3, and that is 19. So off of my window, but I'm just going to keep that in mind. Okay, now the whole purpose of understanding this graph is to solve the inequality. So figure out this thing here. Where's my graph bigger than 2? Well, here's 2. And to be bigger than 2 means you're above it. You're above 2. So I can actually see the part of the graph that we want to talk about. It's this, and it's this. That's the part of the graph that is greater than 2. If it were less than 2, it would be the part that's in the middle. So my first attempt would be, just tell me the x values where this happens. Well, that's going to be from what looks like -5 down to -infinity, and then from 6 up to, well, not positive infinity, because at 19, it actually equals 2 and drops below it. So like over here, we're limited. We'd have to stop at 19. This one, we can go all the way down to -infinity, and it will never actually equal 2. So here's my entire answer. I'm going to go from -infinity to -5, and I'm going to union that with 6 to 19, and those are the two pieces of the graph where it's always strictly bigger than 2. And for the last example, same idea. I would like to solve this linear inequality by using the graph. So my same setup as before, I'm going to factor. Let's see, I get x and an x. That should be a -5 and a +3. Yep, that works. And the denominator. Okay, so the denominator is going to be like x plus 5 times x plus 5. But I'm actually going to write that as x plus 5 squared. If you square the 5, you get 25. If you double the 5, you get the positive 10. This is how the equation factors. So this might do something a little bit different on our graph. We haven't really come across one like this yet. But, let's check it out. So again, my x-intercept, y-intercepts, vertical and horizontal asymptotes. I'm going to assume that 1 is the horizontal asymptote. I think it will be. But just listing these things out, my x-intercepts are going to be 5, 0, and negative 3, 0. My y-intercept is going to be a negative number this time. It's going to be 0, comma, and it's going to be negative 15 over positive 25. So it's going to be negative altogether. If I cancel a factor of 5, I get negative 3 fifths. I only have one vertical asymptote this time. It's at negative 5. But the fact that the exponent's squared leads me to think that it's not going to be split in that one goes up and one goes down. It might be like the same on both sides. More on that in a second. And then again, y equals 1 is going to be my horizontal asymptote because the ratio of the numbers in front of the highest powered x terms are both 1. So if I draw my graph, I have y is equal to 1, my only horizontal asymptote, and negative 5 is the only vertical one. I have two x-intercepts. One is at negative 3, and the other is at positive 5. Okay. I then have negative 3 fifths, and what's going to happen at x is equal to negative 5? So at this vertical asymptote, the graph is actually going to go up on both sides of it. So if I sketch my graph, it's going to come down, it's going to go through this point and that one. It then has to come back up and start approaching the asymptote from the other side. And then here, it's going to drop down and approach y equals 1 going in the other direction. So this will be a sketch of the graph. And I can actually see, again, a place where it's crossing over y is equal to 1. It's like right about there. I want to figure out where that x value is. So I'll go back to my original function, which is x squared minus 2x minus 15 divided by x squared plus 10x plus 25. And I'm going to let that equal 1. You could probably skip this step at this point because you're going to cross multiply. And you'll have that the two are equal. And as before, the x squared terms are going to cancel. I mean, really, you could just copy down the negative 2x minus 15, set that equal to the 10x plus 25. I'll add 2x to both sides and subtract 25 from both sides. Okay, so we have negative 40 is equal to positive 12x. Dividing both sides by 12 gives me negative 40 over 12 is equal to x. And so that's negative 3 1/3. Okay, now to figure out where the graph is less than or equal to 1, I can actually see where this is. So I'll try to like trace over it. So here it's equal to 1, and below 1 is referring to all of this portion of the graph. Now, we figured out every spot where the graph equals 1, so I know it's never going to equal 1 over here and then cross over. So my answer is going to be everything from negative 3 1/3 to positive infinity. And again, I'm getting that directly from the graph of this function.